Hello guys, so we're back. So before I start this, you know, before I start preparing this laptop, shout out muna kay Sir Red Cafe. So he is the one who gave me an idea how to fix the printer Epson 3110. So sir, thank you sir for the idea. So that is a flex cable problem. So thank you so much for that sir. So although we are a technician, but then not everything we don't know not everything that the other person know is also we know it. So we just gave a little bit of uh, information how to fix a problem, the printer or a laptop, but then not all the problem we can fix it by our own way of fixing it. So we will just ask other person to help us how to fix it. So that's what we do by Sir Red Cafe. Thank you so much, Sir Red Cafe. Okay, so if you are new into my to my channel, so please don't forget to subscribe, then click the notification bell, so just select all for you to be able to be updated in all my videos uh, to be uploaded soon. Okay, so let's get started with this. So this is an ASUS laptop. The name of this ASUS laptop, so this is ASUS X441S. I don't know if you can see it because it's blocking the view. The lights on the back part. Okay, so the problem with this laptop is no display, not charging. It is considered as dead system. Okay, so let's plug in the charger so for us to be able to check if it is really working or not. Okay, so based on this, okay, see that based on the indicator lead, so we don't have the lights there. So upon plugging in the charger, so we don't have the lights there. Even when we press the power button, so we don't have any response there. So it has a two indicator lead. One is for the charging lead, then one is for the processing lead. Okay, once that the um, laptop is turned on, so it will blink yellow here, then meaning that it is turned on, or white, and this one is orange, I think, or maybe yellow or whatever you call it. Okay, so let's unplug this one. So actually, I remove this one. I remove the so the all the tornels, all the tornels. So from that, uh, then we will just remove this one. Oh, oh my god. Oh my god. Okay. Let me use this one. So this is a part of, this is really okay. Okay, so this is what we got here. So let us put it there, and let us remove this one, and this one, the LCD connector. Okay, so this is our board. So let's put it there, then we will remove this one, and let's put it on the ground there, because our table is, uh, it is really small. My table is really small here. Okay, so let me set up first the camera. I'm gonna post this one first. Okay, so we already set up the camera here from my microscope. So I hope you can see everything, uh, even though it is really smaller. But then I know it could give you an idea how you're going to fix the problem. Okay, so let's start with. So let us plug in the charger. Okay, so still we don't have lights there. So on that part, so we don't have lights there. So the two indicator lead from the charging and from the power button, from the power lead, I think. Okay, so this time we will check if there is a current that moves through. So let's check first the charger. So let's check first the charger if it is really working. So let's put this one into. So I hope you can see me there. Okay. So I hope you can see that. Okay. So let's check first the charger. So let's check first the charger. So we have here the positive and the negative. Okay, so from the reading we have a 19.4. So the charger is good. So we don't have a problem on the charger. Okay, so let's put this one into the charging port. Then let us check the if there is a current coming from this port. Okay, so it's negative on the black probe. I hope you can see that. It's too high, I think. Okay, okay. So then from the positive one. Okay, so we have 19.4, the same 19.4. Okay, so this time we are going to look for the first and second MOSFET of this ASUS laptop. Okay, so in this case, it's really hard to know because the power rail from here, so it's end here, then it is being cut here down to there. So, but then when we think about it, so it is connected from here, then from the inside of that going to this one, up to this part, then from this capacitor, if it moves here from the controller, so this is the first and second MOSFET. So maybe this is the power IC. Okay, it's power IC. So let's check first the power IC if it is working or not. Okay, negative. So let's just put it there. So I hope you can see what I am doing here. So take note that is always the first and second MOSFET or the power IC is always near on the uh, charging port. Okay, so let's check if there is an 18 volts there. So from the input, so we have a 19.4. So that is a 4 pins, 19.4. Then from the output, let's check if there is an output. Okay, so we have only 1.0 uh, 0.5. So we are expecting a 19.4, and they are all the same even in the drain. Uh, the source, then the output. Okay, so we still have 0.5. So that's the problem. So from the second MOSFET, so we have, okay, still the same, zero point 0.5. That is from the drain, then the output is zero point 0.5, then from the source. So from the source, so we have also a zero point 0.5. So let's check the capacitor here. So the capacitor which is connected to the input of this first MOSFET, it has a 19.4, but then on the other side we have 0.5. Okay, so meaning we have a short here. So we have a problem. Okay, so let's check this capacitor. So we don't have a reading here, only that a zero point 0.5. Randomly we will check the capacitor. Let's check this one. Okay, so we don't have a reading here, even here. Okay, so we don't have a reading. Okay, from this part we don't have a reading. This is randomly. What I'm doing is random checking of those capacitor. Okay, so from the back part of this board, so let's check the other IC if there is a 19.4 volts. Okay, so take note, we are using multimeter and under voltage, so that is under the direct current. So we set it into 100 volts, not on the 20 volts. So we just want to make sure. Now, you can use the 20 volts, but then it is good to use the higher voltage. Okay. So let's check these three MOSFET here. So the IC, these three MOSFETs here. So let's check from the input if there is a 19.4. So we don't have any 19.4, only that we have a zero point 0.5 or 0.5. If you can see it into my multimeter. Okay, so on the other side from the output, so we don't have an output here. Then from the input of this second MOSFET, so nothing, no reading on that. Same with no reading and no reading. So let's check the other ICs here for the MOSFET. So they call it as MOSFET. So we have a zero point 0.8. We have a zero point 0.8 here, 0.5. Of course, every MOSFET has a different reading, so that is common. So what is on this part? There is something. What's wrong with this? I think someone removed. What happened to this? Okay, maybe this board has been checked by the other person because we have a blank part here. Okay, positive, negative, positive, negative. Okay, but then, okay, so let's continue. Although we have loose part there, I think, I don't know, maybe, I don't know, I don't think so. So where we are, so let's check the other capacitor if we have a reading. So still we don't have a reading there. Then okay, so from here, so we don't have a reading. Okay, okay, So this time, let's check if we have a shortage from the capacitor. So we will remove the charger. We will set the multimeter into connectivity. Okay. So connectivity is the best way to check if there is a shortage on the board. Because we can easily check here if there is a shortage on the capacitor. So very easy. I think if it is, or if it has a shortage on the capacitor, so maybe the problem is the capacitor. But then if the board has no power, no output, or no display, or dead, then we don't have a shortage on the capacitor. So meaning uh, we don't have a problem on the capacitor, but then we have a problem on the IC, or the MOSFET, or what you call it, MOSFET. Okay, so I hope that is really clear. Okay, so this time let's check if there is randomly, let's check if there is a shortage. So we don't have a shortage here, so 106.106. Of course it will give us a sound because it is the negative side, or the, you know, the ground part of the capacitor. Okay, so we don't have a problem here, so we'll just check randomly. Okay, so we don't have a problem here, but on this one, okay, so we don't have a problem here, we don't have a problem there, we don't have a problem there, still we don't have a problem. We are just checking this one randomly. Okay, hopefully we could fix the problem this board. So this is an ASUS X441S. Is that correct? I don't know. We just check it randomly, because when we check it everything, every capacitor, I will just lose your time, you know. You're just wasting your time, you know, if we do that. So randomly is good, because we can see if there is a, you know, shortage on the capacitor. Okay, so we don't have a shortage there. So I just want to hear a long beep between the two edge of the capacitor. But then I don't know if there is. Okay, on this part we have, but then it is on the processor, so that is common. So on the processor, so that is common. It's common that we have a shortage in the processor, because you know it is really intercorrelated or interconnected into each other. Okay, so I think we don't have a problem on the capacitor. We don't have a problem on that. So let's go back here, because this is our suspect. So we just move around by looking um, if we have a problem on the capacitor. Then this time, so we don't have a problem on the capacitor. So I think, maybe I think, I don't know. So let's go back here. Okay, negative. So let's check the other MOSFET. So let's go back to 200 volts, or you can use 20 volts because it is lower to 20 volts, but then I am using 200 volts just to make sure, you know. So we plug in the charger. Okay, so let's check it once again. So from here, so we have a 19 volts there, 19 volts, 19 volts here. So this is the power rail of the charging port. Okay, so let's go back to the IC. From the IC, we have 19.4 and the same width, 19.4. But then on the output, so we just only have a point 0.5. I think that is a point 0.5. Okay, so this is what we are going. Because this is our suspect, so we have a problem on this MOSFET power IC. So because we have a problem on this one, so we'll remove this one, then we will look if we have the same MOSFET, the same number or the same MOSFET for this one uh, to be replaced, because we need to replace this one so we can check it. So we don't have a shortage on the board. So from that, we will think how does uh, the laptop does not power on even though it has no shortage. Diba? It's hard to think, diba? When you but then when you think deeper, when you think out of the box, so try to analyze it. Why it has an input but then it has no output? Think about it. That's the best way. That is the very good question. Okay, so we will remove this one. So let's remove the so let's remove this. Then we will apply flux here. Then we will remove the MOSFET or the power IC. I think that is a power IC. I don't know. I don't have an schematic diagram for this board, and even on the other board, I don't have any schematic diagram, and I never use schematic diagram. Maybe I'm just basing on my experience, you know. So I'm using that at liquid flux because I know that this is more. So this is more, you know. Uh, so this kind of flux, this is a kind of flux that I use because, you know, I don't know. This is very effective on my part. I don't know in your part. Then let's do not talk about it. It's your own. It's my own. You know, something like that. So we remove the MOSFET. So this is the MOSFET. Come on. Of course. Come on. Because it has a flux, of course. Okay. So this is the MOSFET. I don't know if you can see it. Okay, so that is the MOSFET that we remove. A MOSFET. Yeah. Okay, so that's it. Okay. You know, so because um, I don't have, I don't have an IC like this, even though I have many laptops here and then laptops, but then I don't have any rights to get, you know, to get their to get their parts, the parts of their laptop. So I don't have a rights to remove it, then put it here. Sorry for that. Okay, so the name of this is M3056M and 722 and 06E. So that is M3056M. Okay, so that is the name of the MOSFET. I think that is the power IC. So we'll just put it there. So we don't have anything. Then we will check. You'll check it if we still have 19 volts from the input. Okay, so let's plug in the charger. Okay, negative, positive. Okay, 19 from the output. Of course, we don't have even a 0.5. Okay, still we have a 0.5 here because it moves on the other part of the components of this board. So that's why it has a 0.5. But then, so it means that we remove when we remove um, the capacity the IC there, the power IC here, so the first MOSFET. So when we remove it, so we have a 0.5 reading. So this time we still have a 0.5 reading. Then this is a 19.4. Okay, so of course that is our suspect. Okay, this time um, I'm using some trick. I don't know if you like it. I don't know if it is really applicable for you. But then, what I am going to do is to jump this one. I will jump. Sorry, I don't have a COVID. I don't have a COVID. I will jump this one. Then let us remove first um, so I just only have a limited, yeah, a limited outlet here. Let me post this one. Okay, so while we are waiting for the iron to, you know, make it hot, so let me give you a trivia. When you are replacing an IC and when you remove an IC, I mean, when you remove an IC, then you don't have anything to replace it with, then you will just jump it. Never, never ask for a higher price on your customer. Never ask on that. So if it is really easy, so in Bicol, so that is taga. So huwag mong tatagain sa presyo yung customer mo. Because you just work for it and you don't have nothing to replace with because you jump it. I know that some other they're doing their part just like that. Although the board, the um, they fix the problem of the laptop, but then it is not good. Okay, so let's continue. I'm too, you know, dramatic here. I'm just only one here, the second floor of my house. Okay, so I think we need a flux here. So let's put first a flux here. Sorry for that. I have my coffee now, and it's really cold here. So we'll just put so additional lead here just to connect it. So it's not really hot. So the iron is not really hot. Why? Maybe it's too early. Okay, so let me show you this one. So I hope you can see that. Okay, so I think you can see it. So this is the MOSFET or the IC that we are going to jump it. So from this part, from the input going to the output or going to drain. I don't know. I don't know if I am correct. So just correct me if I am wrong. So we will jump this one going to that part, but not on the output, only on that. Not on the source. Is that a source? I don't know. 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 Okay, so let's get some wire here. So this is the wire we are going to use. I don't know if you can see it. Okay, so that's the wire. I'm just only referring to the lights of my microscope. So we are just removing the cover of this wire for us to be able to connect it. Okay, so let's connect this one. I can't see it. Okay, so that's better. That's better. Okay, so let's connect this one. So I hope you can see what I am doing here. So my soldering iron is not really hot. Maybe I need to replace my soldering iron. No. It's okay now. Okay. Sorry for that. Having my coat. Meron akong ubo. But then I don't have a COVID. I'm not going anywhere. I just be here into my house. Okay, so let's fix it. Let's fix it. So we need to cover the both side for us to connect the wire. Okay, I think that's it. And let's clean this one. So let me clean this first. So I'm using a lacquer thinner to clean the board. This is what I use. Lacquer thinner. So this is available in all hardware. So, iba yung paint thinner, ha? Iba yung paint thinner, iba yung lacquer thinner. So, they are different. Okay, so I think that's it. We'll just wait to dry it. Then after that, we can test if it is working now. So hopefully, this will work. Then we will check everything if there is now a 19 volts on the other ICs. Okay, so hopefully you could fix this one. Okay, so let's proceed. I think that's it. We will let it to dry. Yeah. So we need to connect now the charger. So where's the charger? Charger, where are you? Here. So here is the charger. Okay. So the lights, the indicator leads is there. So let me put it down there. So I hope you can see it. Okay. I think you can see it now. Okay, so let me plug in this one. Hopefully this will not spark. Okay. Okay. Wow. What a nice job, So we have now a lights there. You can see it. So let me turn off this one for you to be able to see it. There, lights there. So we have now a lights there. Okay. That is a good sign. That is a good sign. That is a very good sign. Wow. Very good. Okay. Good to know that. Okay. So let's check if there is a 19 volts that comes out into the MOSFET that we remove because we jump it. So from the negative, so let's put it from negative. So here's okay. So I never set. So ito yung problema ko kasi lagi akong puyat. So ito na, lagi na akong inuubo. Kasi alam niyo na, kulang na ako sa tulog eh. Pwedeng ano na ako, ano bang tawag doon? Low blood ganon, I think. Maybe. Okay, so let's check it. So hope you can see. See there. Okay, so that's better. I think so. Okay. Sorry for that. So the same with under voltage 200 volts. I set it into 200 volts. So let's check. So from the input we have a 19.4. From the output we have a 19.4. Then from the other IC, the next MOSFET or the second MOSFET. So let's check it if we have a 19 volts there. Of course it has. Of course it has because it has a lights there. So still on the output, so we have a 19 volts there. Let's check randomly the other MOSFET here if we have a 19 volts on the other side. Let's check if we have a 19 volts on the other side. Check from this one. Okay, so we have a 19.4 volts. So I think that's it. Okay, so I think this one is working. Okay, so let's try to turn this one on. Okay, so I hope you can see it. There you go. we are going to expect that this will lights on because this is the power lead. Okay, power because the charge lead or charging lead, then the power lead. Okay, so because we don't have, we are not going to connect this one into the power button. So from here, so because the power button is under the keyboard, or it is a part of keyboard, so it is one of this one from the pins here. So from the keyboard, from the keyboard. Okay, so let's try to connect. Let's try to connect. So maybe they are just only on that part and on this part from the first second pins. So let's check. Okay, so from here, let's check. So it is not working. Let's check. So now from this part, okay, it's not connected. Okay, so did I am doing it good? I don't know. I don't know. Maybe I am doing not the right thing. Okay, so on this one, so this part is on the power button. This first and second pins. Okay, so meaning it is now 100% working. As you can see that. So we have now a charging lead and the power lead. Okay, so that's how I used to, you know, that's how I used to perform a job, troubleshoot a problem. So it is now 100% working because we have a lights there. It is 100% fixed. Okay, so let's power this one off. Power this off. You can see it. So let's power this off. So let's connect the both just to turn this off. I don't think if they are connected. First and second pins. Long press. For the power button, that is a long press. Okay, I will just remove the charger. Maybe it is not really connecting. Okay. Okay. So let's talk about this. This is 100% working. You So that is what I did into this one. So what I did is to jump. So you don't have to replace. So you don't have to replace it. So if you don't have, there, if you don't have an IC, then just jump it. But then I think this is only applicable into a flat IC like this. So not on the, so an IC like this. So it is only applicable on IC like this. But then on the other IC, I don't know if they are applicable. So that's what I did. I just only jump it and it works. So it is now 100% working. Okay, so let's check it once again. I will just use the keyboard. Just put the keyboard here so that we can see if it is really working now. So maybe because it is, or the power button is a part of the keyboard, so if it is will not work, so maybe we have a problem on the keyboard, so we need to replace it if that happens, so let's plug it in. So can you see the lights there? Okay, so that's the lights. Okay, so let's press the power button here. Okay, so it is now working there. 100% working, so let's power it off. Long press. Okay, so there you go. So the power button is really good. It's working correctly, perfectly. Okay, so I hope you like the video. So if you are a new viewer into my videos, so don't forget to subscribe. Then for you to be able to be updated, so all you have to do is just to click the notification and select all. So I think I need to take a rest because I have serious cough. So maybe I will just handle this tomorrow. It is now working perfectly. Yeah, really. So I hope you like it. Thank you so much and have a great evening. So can you see my eyes? So I need to rest. So I will just fix this tomorrow. Thank you so much and have a great evening. This is your Sir Alden signing off.